All right, so welcome to the basics of converting between standard notation and scientific notation. All right, the number I have written here, 2,454, that is expressed in standard notation. That's how most people express numbers. Right. In scientific notation, however, there's a specific form, and the form is written as this: n times 10 raised to the a power, right? Where, and this is the important part, n has to be less than 10 and greater than or equal to 1. So that's a little abstract. I'm going to kind of break it down and simplify it a bit. So if I want to take this number right here, which is in standard form, and put it into scientific notation, right? I know that I need to have I need to have a leading number times 10 to the something power. Okay, so I'm kind of like filling in the blanks. Now, let's think about the first thing I like to do. Where is my decimal in the original number? And my decimal's right here. Okay, now I need my leading number to be less than 10 but greater than or equal to 1. So I'm actually going to move it to the left, 1, 2, 3, so that my leading number can be 2.454. Okay, again, that satisfies this requirement that the leading number has to be less than 10, greater than or equal to 1. Now we need to think about the exponent, what needs to go in this box right here. Well, I'm trying to get this number, okay, this leading number to match the original number that was in standard form. Again, we're not like changing the material value of the number, right? We're just expressing it differently. So if I think about it, right, like let's test this and say 10 to the negative third. All right. Well, we learned from simplifying with exponent rules that we can't have a negative exponent. So this would actually be, this part right here would actually be 1 over 10 to the third. So I'd be taking 2.454 times 1 over 10 to the third, which in this case, again, would actually be something like this: 2.454 divided by 10 to the third. 10 to the third's 1,000. Okay, so this is not going to end up to 2,454, all right? So we know that it's not going to be a negative exponent. Instead, it's going to be a positive 3. Okay, it's going to be a positive 3 because when I have my exponent as a positive, really this is saying times 10, or excuse me, this is this portion right here, 10 to the third is 1,000, and if I do 2.454 times 1,000, that's going to bring me back to 2,454. Again, you could put that in a calculator just as verification. All right. So that's sort of the basics of scientific notation. We'll go through another problem right here. We'll go through another one. All right. Let's say I had this number. Let's say that I had 0.0023. Okay, and that's in standard form, and I want to put it in scientific notation. So the decimal here in standard form, it's already shown. Okay, the decimal is right here. Well, again, I can't use 0.0023 as my end value because it's not greater than or equal to 1. So I'm going to need to move my decimal to a point where I get a number, in this case 2.3, that satisfies this requirement, satisfies that condition, that parameter. All right. So I have 2.3 as my leading value. Now I need to think about times 10 to the what power? Well, I moved it 3 places, but if I put 3 right here, then again, 10 to the third is 1,000, right? So 2.3 times 1,000 is most definitely not going to give us 0.0023, right? And you could check that in a calculator. So then logically, all right, it has to be raised to the negative third, all right? So th- there's a couple different ways you can think about this conceptually, but again, the way that I like to do it is thinking about, all right, this is my original number right here, the 0.0023. Okay, when I rewrite it in scientific notation, both of these need to be equivalent. All right, so you're not changing the value of the number, you're just expressing it differently. We will continue this in another video. Thanks. Bye.